Hello everyone. We are looking at phase 3, chapter complex number, exercise 2 from a package. And we are at question number 23. So if you just look at the question is that we have been given an expression and we have to basically come to the conclusion that it will not have imaginary roots. Okay, let's first unpack the question. What is the meaning of it? So it is telling that if A, B, C and small a, B, C and everything that is involved, they are all the variables, they are all real numbers, then we cannot have an imaginary or a complex number with imaginary part substituting it. X cannot be an imaginary number. So basically X, let's start with taking X as any complex number with both imaginary and real part. So if it is a possibility that this X can also, okay, because X is already, so this side is also X. Let us substitute X and then we see, because we have to see that imaginary roots it shouldn't have. So basically put it back into the equation and equating the real part and imaginary part. So because we only have to look at the imaginary part, so we have to see whether imaginary part is possible or not. We don't have to find it. All right. So we don't have to find it. So what we do is take the first one, a square, and then p minus a, because a is real. So p minus a into plus iq. Yeah, plus iq. Now I'm just taking this one. So how do we manage it? Because we have a complex number in the denominator, so we take it up. So it is nothing but a square into p minus a. Oh, let's write it properly. A p minus a minus iq divided by p minus a whole square plus q square. It's a very basic thing. Whenever it is in the denominator, this is how bring it. This is how all the other parts are going to be. This is only the first term. This is how the other terms are going to be. And everything is going to be equal to p plus iq plus l. P plus iq plus l. So now all we have to think about it, because we have to only look at the imaginary part. So if we just rearrange it into imaginary, so a square to a square, and then p minus a minus I minus a square into iq divided by this thing. So p minus a whole square plus q square. This time also p minus a whole square plus q square. So what has happened here is that this is the real part in the entire expression, the first one, and this is the imaginary part. So we are only interested in the imaginary part here of all the terms. So all the imaginary part is going to look something like this. So let's look at the imaginary part everywhere. So let's look at the imaginary part, only combining the imaginary part. Only combining the imaginary part. Only combining the imaginary part. So we have minus a square q divided by p minus a whole square plus q square. And if I am taking minus bahar, so it is going to be, the next one is going to be by symmetry, b square into q divided by p minus b whole square plus q square, and so on. And this is going to be equal to, this is going to be equal to q. So we can see, we can take q, we can bring this also inside, and we can say this is equal to 0 because we are equating, so we can bring it here. And now if we take q common, then this whole thing and also minus common. So this will become 1 plus a square divided by p minus a whole square plus q square plus b square divided by p minus b whole square plus q square and so on. This is equal to 0. Now we come to the known thing, like q is equal to 0. So there are two factors which are giving us 0. Either q is 0 or this entire expression is 0. So if q is 0, the imaginary part is 0. And if this is equal to 0, so we have to basically explore, is this a possibility? Because if this is equal to 0, then we have come to the conclusion. Is this going to be 0? Is it possible? If we look carefully, this is all positive term. They are combination of squares. They're always going to be positive. Now, how can this be equal to minus 1? Because they're all real numbers. So their square is also going to be positive. So it cannot be that this is equal to minus 1 to make this second term equal to 0. So that only leaves us with q being 0. If q is 0, then we come to the initial conclusion that x cannot have an imaginary part. So I think explanation is also pretty much similar here. But all we have to do, even if it is looking a little bit complex, how to, these type of questions we are going to go further. Always, whenever we see such a complex summation or something, it is always better to unpack them. And we don't have to write all the terms, just few terms, 1 or 2 terms, and then we can figure it out easily. So here also we saw that the terms were all squares. They could have been equal to minus 1. So that's what, this is a good question. It's a good question. We advise the students to go through this question once more and do it yourself so that you become comfortable with this kind of complex looking question in complex numbers. Complex. That's all. Thank you.